Welcome to our fax devices lectures. We shall discuss today a new topic, that is flexible AC transmission system. For the subtopic will be essentially the UPQC and its introduction and classification. Abbreviations of the UPQC stands Unified Power Quality Conditioner. There will be another term we will also discuss, that is UPFC. So, let us see that what are the features of the UPQC. So, main objective of this electric utilities is to supply their customer an uninterrupted sinusoidal voltage at constant magnitude and the frequency with sinusoidal balanced current at the AC mains. So, we require the quality power to be available to the customer. So, that is the responsibility of the power utility companies. Unfortunately, due to this disturbance in the transmission line, the sag, swell and the harmonic contaminations due to the fax devices, you do not get the customer does not get the desired power quality. So, one of the solution to this actually given to this customer by this UPQC. At present, the AC distribution system are facing several power quality or PQ problems such as high reactive burden, unbalanced loads, harmonic rich load currents and excess neutral currents. All are the actually dominating features that decreases the power quality to the consumers. In addition, these utilities are not able to avoid voltage sag, swell, surges, snotches, flickers, spikes, unbalanced and harmonic in the supply of the voltage across the consumer to the load. And what happened, this kind of phenomena or occurrence may destroy our sensitive devices. I am a customer, so I am talking in a customer point of view. It may destroy the household utilities, like there will be a blast furnace in the campus and thus we get a poor power factor and thus my utility get damaged and destroyed. So, it is not acceptable as a customer, and for this reason nowadays actually it is a responsibility of this power quality people to deliver a clean power to me and also penalize for whom that power quality get distorted. So, for this reason this power utility company either penalizes the people who actually pollutes this power quality and fix it up with the method which we will be discussing in future, or they will ask that power quality that pollutant consumer to actually clean up the mess. Either of it is possible, and both the cases ultimately we have one panacea, that is the UPQC. The customer power device is known as the customer power device known as unified power quality compensator or condenser, we shall use synonymously, is considered as a right option for critical and the sensitive loads to compensate both voltage current based power quality problem. See that ultimately this is basically a series DVR which is essentially a series compensator, and we also have a D-STATCOM that will basically compensate the current, that is a shunt compensation. So, it is a combinations of the series and shunt. So, advantage of it, so thus it inherits the advantage of series and shunt both. The UPQC is a combination of the shunt STATCOM and the series DVR compensator, as a single solution for mitigation of this multiple power quality problems in voltage and current. Generally, you have a critical load that require to be supplied the clean power. You always supply the clean power irrespective of the load and the source disturbance. The power circuits of the UPQC, what we have discussed earlier, let us formally describe it, consist of the two voltage source converter or a current source converter, but nowadays voltage source converter is preferred because size of the DC link will be lower, we require a huge size of the inductor. Joined back to back by a common DC link capacitor or an inductor at the DC bus respectively. We generally do not connect inductor because size of the inductor will be very high, but it is a possible solution. Shunt device of the UPQC is known as the DSTATCOM, which we have discussed in while discussing the STATCOM. Total design and procedure has been discussed. Provides reactive compensation, load balancing, neutral compensation for 3-phase 4-wire system, and elimination of the harmonics, that is we say that a shunt active power filter, and it is connected in parallel to the consumer load. So, it is a shunt compensation. Shunt compensation will do this job, and series compensation, which is essentially a DVR, series devices of UPQC, also known as DVR, dynamic voltage restorer, keeps the consumer load and the voltage insensitive to the supply voltage quality problems such as sag, surges, spikes, notches, fractulation, depressions and unbalance. So, these are the problem that will be mitigated by the series component of the UPQC. DVR injects a compensating voltage between the supply and the consumer load and restores the load voltage to its interface level. A UPQC essentially, which is a combination of the shunt and the series compensator, proposed a single solution for mitigating the multiple PQ problem. We have seen the problem arises from the current part, we have seen the current problem arises from the voltage part, both it can mitigate. The cost of power quality to manufacturing and the emergency services together with requirement of improved power quality in the current waveform justifies the cost and the complex control required for UPQC. And however, day by day cost of these devices are coming down, and for this reason UPQC is has got huge potential in present as well as the future. Not only the cost of the devices, but also we have a very fast processors, and these two combinations enables us to effective UPQC solutions. There are many control technique and the topology reported to control the UPQCs. We shall take few important UPQCs. The energy storage element at the DC bus also used for the operations of the operation as an alternate of the unified power flow conditioner. Then real power exchange is also possible, and that can be used to reduce the peak demand capacity, which is also a huge scope of research as well as utilization. DSTATCOM and DVR are controlled separately for power quality enhancement for current and voltage respectively. DSTATCOM is for current harmonic mitigations and other current related issues, and voltage flickers, voltage harmonics are or voltage sags or swell are the part of the DVR. Most of the control algorithm reported for the DSTATCOM and DVR are applied for the UPQC. Essentially, you put separate processing unit for as well as the STATCOM and DBA, it should work. But there is a little change of the control circuit when you are using in a unified mode. So, instantaneous reactive power theory proposed by Akagi et al. And all those fellows in 1984. Synchronous reference frame proposed by Deepak Devham, Subhasis Bhattacharya et al. And thereafter there are many different kind of soft computing based reference generation technique like instantaneous algorithm, fuzzy logic control algorithm, instantaneous symmetrical component theory, it is Akagi and Nobe both were proposed that, and the neural network theory, and there is a wavelet based theory. There are so many, there is also time domain as well as the frequency domain. These all are discussed, please refer to our discussion in DVR. Are some control approaches reported in the literatures. The 3-phase 4-wire system, a neutral current compensator along with the other UPQC function. So, if it is a 3-phase 3-wire system, you have only positive sequence or the negative sequence, 0 sequence is absent. So, in case of the 3-phase 4-wire system, the 0 sequence or the neutral current has to be also compensated. So, for this reason algorithm little changes. For this reason you got a instantaneous symmetrical component theory is one that fits well in case of the 3-phase 4-wire system. So, let us classify the UPQC. Please note that UPQC actually put into the distribution level. Transmission level discussions will be done after few classes once we discuss UPQC thoroughly. The UPQC can be classified in many based on the supply. For example, 2-wire, it may be single phase, it may be 3-phase 3-wire, it may be 4-wire kind of UPQC, and also converter based UPQC, that is voltage control or the current control. Most of them are voltage control because of the size of the inductor. So, topology wise UPQC may be 2 types: current control, current source inverter and the voltage source inverter, and mostly we have a voltage source inverter. It may be actually 1-phase 2-wire system, that is for single phase system, that is for the 3-phase 3-wire system for the data connected line. This is mostly in a little higher distribution line, and this is mainly the distribution line 3-phase 4-wire system fitting single phase, and mostly in case of the 3-phase 3-wire system, because voltage level has to be little higher. So, we have 2 level as well as the multi level. In case of the 2 level, we can have many combinations. Of course, it can be extended to multi level inverter, it is not that it is possible, but number of switch will be huge. The conventional 12 switch topology, that is for the 2 level. So, reduced decelling voltage based UPQC, we shall see these topologies, and thereafter instead of the 12 switch we can have a 9 switch topology. There are combinations of, there is a some switches has been shared between series and shunt. So, that is the reported topology, and 10 switch topology also same thing. These are the reduced switch topology, ultimately it shares the part of the current as a voltage. So, it is a one leg or something is common for both. So, that it reduces the number of switches. Now, let us put it in a formal way. Classification based topology, that is right shunt and the left is there is whether it is right shunt or the left shunt. Please go back to the figure, then only you will appreciate it. So, see that here it is a right shunt topology. We can put this side, then we say it is the left shunt topology. So, we can have both. So, that is right shunt and the left shunt UPQC. Classification based on method of control, you may have reactive power injection, then we say that UPQCQ. We may have UPQCP, that is in phase component, and UPQCS, that is the apparent power based UPQC. UPQCQ, a DVR is used in series voltage injection in quadrature with the supply current with almost 0 active power injection. Then you say that it does not have any reactive power, any real power handling capability. Same way, if it is UPQCP, DVR used in series injection in phase with supply current, only the active power injection, it will inject only the active power. And you may have a S, that is a combination of it. DVR is used for the series injection of the optimal phase angle to increase the effective power handling capability of the line, and phase angle with maximum kVA of S. So, these are the 3 mode of operations of UPQC, and this is the overall classification of UPQC. Students are requested to actually keep this slide in their mind. So, one is physical structures, another is voltage sec combinations. Best classification is based on the physical structure as well as the voltage sec combinations. If it is based on the physical structure voltage sec combinations, that is UPQC P, it will inject only real power. UPQC Q, that only inject in a reactive power, voltage inject in a quadrature to the supply voltage. So, UPQC VA minimum, it stands for the minimum VA loading. So, rating of the switches will be reduced, and UPQC S, where actually apparent power, it will act on apparent power, the apparent power rating is constant, it can compensate same amount of the, it can go to the kVA rating, it is been fixed. Similarly, based on the physical structure, we have a converter topology, that is the first classification, that is based on the voltage source inverter or current source inverter. We generally use voltage source inverter, we have said repeatedly. Similarly, based on the supply system, we may have a single phase that is not very frequently used, and we have 3-phase system. And for the single phase, we try to reduce the cost, and thus we have a reduced cost topology are very popular. So, for this reason, and rating of these devices is also low compared to the 3-phase rating, and there for this reason we have a total 8 switch normal topology, and there might be a 3-leg 6 switches topology, where instead of the 4 leg, 1 leg is shared by shunt and series both, and the half bridge topology that consists of the 4 switches. Each has its own advantage and disadvantages. So, generally the conduction ratio of this reduced switches is more, and there is no clear cut distinction between the shunt part and the series part, and half switch actually switch rating is going to be double, but it fits well in case of the single phase where rating of the supply voltage rating is quite low. Same way 3-phase, we may have a 3-wire or 4-wire. 3-wire again we may have a normal 12 leg topology or the reduced topology, and in 4 leg we have few more options, that the 4th leg can be connected. We can put a 4 leg with the shunt part, we can put them middle point of the capacitor, that is the split capacitor. Again we can have a 3 H bridge topology also, and based on the system configuration, UPQC R, that is right shunt, shunt is connected right side of it of the load closer to the load, left shunt, shunt is connected closer to the source. It can be interlean, that we will discuss in future classes, and UPQC MC, that stands for the multi converter, it can be cascaded one, and it can be UPQC MD, that can be modular one to increase the rating of the devices, and it can be ML, that stands for the multi level, because to support the high voltage the rating of this single switch may not be possible. So, you require to have a cascade switches, and mostly you are discussing UPQC D, that is used for the distributed generation, for the distributed network or distribution network, and UPQC DG, and that is very famous nowadays, that is distributed generator integrated. So, that is actually maybe the solar panel incorporated with it, that kind of thing. So, based on this classification, let us understand how UPQC works and which one you will choose and why those first classifications has been put in. Two types of converter are used, that I have told repeatedly, used in development of the UPQC. One is VSI, another is CSI, but CSI is actually we do not use very much, VSI is preferred. VSC, voltage source converter, based on UPQC has many advantages over current source converter UPQC. In current source, a diode is used in series with the self commuting device of IGBT for reverse blocking. For this reason, what happened, the current source converter UPQC is considered sufficiently reliable, but since these two switches comes into the parallel, switching losses will be more, but have a higher losses and require higher values of the inductive energy storage. So, size of the inductance will be very high, since diode and the IGBT comes in series, their losses will add on, and consider that it is feeding 1000 ampere of current. So, both the top will add up, and that gives you a basically lossy entity. Storage at the DC bus, which is bulky, noisy, because of that switching may be actually below our audible range, that is 20 to 20 kilohertz. So, that is generally 1000 hertz. So, a cranky noisy sound will come out from this actually the inductor, and has high level of losses. So, due to this disadvantages, we generally do not use current source converter. Moreover, it cannot be used in the multi level to improve the performance of the higher rating, and output current CSI is pulsated format. So, these are the actually disadvantage of this current source inverter, but anyway it is possible to work on it. So, this is a single phase CSI current source inverter based UPQC. Based on all the reasons, the VSC based UPQC have taken a lead almost in all the applications, but we have showing you an application. This is the inductor, the size of the inductor is very high, in the range of the hundreds of Henry sometime, and thus this is the DVR, and this is the portion actually it compensate the D STATCOM, and this is the critical load. Since weight of the inductor is quite heavy, so it comes with the copper and iron, it also bulky, but this is maybe the structures of the single phase CSI based UPQC. We shall continue with the topology based classification of UPQC. UPQC can also be classified based on the topology such as right shunt and the left shunt. It is connected towards the shunt is connected towards the load or towards the source. So, in case of the right shunt topology, which is quite familiar, DVR is connected before the load in series with AC mains using a matching transformer to mitigate sag, soils and the notches. So, that voltage part get cleared up by DVR to balance and regulate the terminal voltage across the consumer load and to eliminate voltage harmonics. So, whatever actually the power quality issue related to the voltage, that it's been cleaned up by the DVR. It has been used to eliminate the negative sequence voltage and to regulate the load voltage of the 3-phase system. Moreover, it can be installed by the electric utilities to compensate the voltage harmonic, to tamp out the harmonic propagation caused by resonance with the line impedance and the passive shunt compensator. So, this is the advantage of the right shunt UPQC, and this is quite preferred because voltage mesh has been already cleaned out, and damping also action can be done by the shunt active power filter. So, thus this solution is preferred. So, for this reason it can model it like this. So, this is actually the source impedance and this is the DVR, ultimately it will inject and clean up, and this is a D STATCOM, and critical load will always see that a very clean power is connected across it. So, it is considered the superior configuration as it reduces the rating of both converter and the control is quite simple, because you have already mitigated the voltage and thus you are getting a clean voltage, and then the STATCOM has to control only the issues related to the current. And same way we can have a left shunt. So, this is the combination. The main drawback of this is actually high cost and the control complexity. Therefore, the right shunt UPQC is considered the better option to deal with. So, this is actually the right shunt UPQC. We shall continue our discussion, that is on supply system based UPQCs in our next class. So, that is actually we shall see that what kind of supply is there, and based on that the combination we can classify the UPQC. Thank you for your kind attention. We shall start out in next class with supply system based UPQC. Thank you.